Okay, yeah.
Good afternoon. Yeah. Okay. Good afternoon. We are Team 5, formed by Estefania Cortés, Isabela Guerrero, Paola Rendine, Manuel Rubio, and Naomi Sepulveda. We will present our PIA of Study of Change of the topic optimization.
Problem. A woman wants to maximize the area of her garden. Her garden, which had a rectangular shape, is to be constructed using a rock wall as one side of the garden and wire fencing for the other three sides, 200 feet of wire fencing. To maximize the space, she has to determine the dimensions of her garden.
Variables. The dependent variable is the area of the garden, and the independent variables are the length of the rock wall and the wire fence.
Solution. To find the area of the garden, we have to consider the equation x variable multiplied by y variable. Uh, we're going to let the x variable represent the length of the side of the garden perpendicular to the rock wall, and the y variable represent the length of the side parallel to the rock wall. Because we want to find the maximum possible area subject to the constraint, the total fencing equals to 200 feet. The total amount of fencing used will be represented by the equation 2x plus y equals 200. Solving this equation for x, we have solving this equation for y, we have y equals 200 minus 2 times x variable. Therefore, we can write the area as a equals x variable multiplied by 200 minus 2x, which equals to 200. X equals, no, 200x minus 2x to the square. Before trying to maximize the area function, we need to determine the domain under consideration. Since y equals 200 minus 2x, the open interval is 0, comma 100. Since area is positive for x in the open interval 0, comma 100, first we have to find the derivative for the area with the equation 200 minus 4x. With this equation, we can find that the x variable equals to 50. Then to find the y variable, we have to solve for 200 minus 2x, substituting x with 50, which equals to 100. Therefore, the area of the garden will be found by multiplying 100 times 50, and this gives us the maximized area, which is 5,000 feet square.
This is a cardboard model of the problem. The smaller square that is in the center, it represents the garden at the beginning, and the larger square that surrounds it is the maximized garden with the feet and length that we established to maximize it, which it was 50 feet by 100 feet, which results in 5,000 feet square.